Just a quick rundown on transformers and what transformers are used for. There are two types of transformers, but all of them have the same basic structure. They have an iron core, and it's designed to reduce eddy currents. So it's made of laminated metal material, sheets of iron core. You have an input side, so from the power. This is AC power. They only work with AC because they need to change the flux through the coils. And we have coils, and this is the primary coil and secondary coil. If there's more coils in the secondary, okay, and this is going to whatever it is that it's powering. We've just put a voltmeter here, but this is a step up because you're getting more voltage. The current goes down, voltage goes up. The power going in, so P equals voltage times current. The power going in has to equal the power going out. It is usually less going out because you lose energy to heat in the process, but in the step-up transformer, the voltage gets stepped up and the current has to go down because the power going in has to be the same as the power coming out. So if one of them goes up, the other must go down to make so that power remains the same. And we have primary and current, secondary and secondary. Now a step down transformer would have fewer coils in the secondary current, in the secondary coil, and more in the primary. So this one here is receiving less flux from here, so less energy is transferred or less current is induced in the secondary coil. The number of turns in these coils, or number of coils or loops in the coils, follows this pattern, and this is in the formula sheet, and you can work out if you have a certain number of coils. This is a ratio here, so the voltage primary to voltage secondary might be 50 to 1 or 50 to 10, and you can look at that directly in terms of the number of coils in each. It would also have to follow the same pattern to make this equal to this. They're used primarily, as I said, in AC, but in power distribution. So when it comes out of the power station, which is producing our energy, we want to step it up immediately, get it up to very high voltage, 500,000 or so, maybe 300,000, depending on where it's got to go and the structures available. Send it, so almost straight away. Over here we then step down in the street or housing area, down to 412 or maybe 240 for houses. And the point of having it very high voltage is less power is lost when the voltage is high. And we can see that from the power equation, P equals VI. And we know V equals IR, and I. So if we put that in here, instead of V we put IR, we've got I, R times I. So the power being lost by this circuit is equal to I squared R. So the higher the current being transmitted, the higher the power loss. So you want to ideally produce a high voltage, remember this, you put the voltage up, current goes down, you lose less power lost in transit or throughout the grid. Okay, just a quick crash course on transformers. Hope that helps.